Previously, I discussed the Laplace transform of a first derivative function, dx dt equal to f bar of t. In this one, we are going to talk about second derivative d square x dt square equal to f double bar of t. Remember, f of t is the main function, and this is the second derivative of f of t using transform of derivatives. But before you start, please locate this video. Transform of derivatives using notations. I'm going to apply some principles here using the notations, and it is very important that you understand this. So you have to watch this one first, because in this calculation I'll be directing you back here. And my name is Daniel. You can call me Danjin. Please take a few seconds to support this page, and let me move on to what we have today. So to solve this, the Laplace transform of a second derivative f bar of t is given by this, the main function, times e minus st dt. You take the integral from 0 to infinity. So we are all familiar with this one. In this question, we have a product function. We are supposed to integrate this. And one of the ways to do this is to apply integration by part. Now, integration by part says that if you have two product functions that are multiplying, treat one of the functions as the variable u and treat the other function as a derivative function dv. You can turn this around. You can use v du equal to u v minus u dv, depending on how you want to turn your formula. It will still give you the same result. So now, how do we know which one of these represents the first variable and which one of these functions represent the derivative function? In this question, it is very simple to locate. Why? Because we have a derivative function, a second derivative function here. So it will be simple for us to represent this with the derivative dv and use u to represent e minus st, the exponential function. This is not so for all functions. Sometimes you just need to pick one of them and use it to represent this, but you need to look very carefully for easy calculation. So from here, let's do this representation and see. Let u be equal to e minus st, and let dv be equal to the derivative function f bar of t. Now, when we look at the formula says the first function times the derivative of the second function, whatever way you want to use it, should give us the result first function times second function minus the integral of the second function times the derivative of the first function. Now, when you look at this very carefully, we do not have the function v. So how do we get the function v? That is where we come here. We need to integrate dv to generate the function v, because the integral of this function will give us what? V. Then, when we move on to this side, we do not have du. Du is the derivative function of the function u. We do not have this, and so since we have u equal to this here, we can differentiate this side to generate this function. Very simple. So now what do we do? First, we differentiate the function u. So du with respect to t, dt is equal to minus se minus st. Why? When you differentiate an exponential function, the coefficients of the variable you have here, we have t here. You use that coefficient to multiply the main function, raise it to the same exponent. Okay, so that is what we have. If this side is negative 2, it will be minus 2e minus 2t. Very simple. I've been talking about this every time. So now, let's make du the subject, since we need to substitute du here. So to make du the subject, this is giving us du, you cross multiply here, this is over 1, we cross multiply here, we have du equal to minus se minus st times dt. Let's move on to this side and find v. Now, because this is a derivative function, we need to reverse it to find v. And to reverse this, we need to what? Integrate. So once you integrate this side, okay, the result gives you v. And once you integrate a second derivative function, you get a first derivative function. So we have f1 or f bar of t. You see, this is very simple. So now from here, we just pick all this result and substitute this into our formula. Now, we have 0 to infinity here, so let me just substitute that here to make it very simple for you to understand. So now watch this very carefully. This part of the equation is representing this one, okay? So this part of the equation is what we have here, and it is equal to, so we are interested in the right hand side. This is just the question, okay? So now let's move here. Now the result says that multiply u by what? V. What is u? U is e minus st, and use this to multiply v. We already know the function v, which is f bar of t. So we have our f bar of t. Now we put this into a square bracket and substitute our lower and upper limit, okay? Because we have a lower and an upper limit here, so you put it there. So minus, we have the integral from 0 to infinity v. Where is function v? This one. So we have f bar of t times du. We already have du here, minus s e minus st dt. So I'll do that, minus s e minus st dt. So now this is the result after substitution. What is the next thing you need to do? We have to look through. When you look here, we have negative s here. We can factorize it out. All right, so when we factorize it out, we are having plus s and then the remaining function. So we can rewrite this by saying this is the same as e minus st times f1 of t. You close this, 0 to infinity, negative s times this, we have plus s, integral from 0 to infinity, f bar of t times e minus st dt. Now, in our next step, we focus on the left-hand side of the equation and substitute our lower and upper limit. So I'll just put in the lower and upper limit to cut it short, all right? So now it is upper limit minus lower limit. First, we substitute t for infinity. So we have e minus s, we put in our infinity, then times our f1, we put in our infinity, then we subtract this result from the lower limit by putting it into the same function, e minus s to 0 times f bar to 0, and that is it. Then we add this side of the equation, plus s integral from 0 to infinity, f bar of t e minus st times dt. Now let me take you here. I've been talking about this every time in these videos. If I have the limit of an exponent, let's say an exponential function e minus t, as t approaches infinity, this result will converge to 0. Why? If you want to test this, pick your calculator, take any random number that will represent t, a very huge number, okay, a number like 1,555,555,555. Substitute it into this function and look at the result. You see that this result will converge to 0. So as t approaches a very huge number, the result is equal to 0. So this side of the equation will generate what? This is 0, this is 0. 0 times 0 is 0. We are not interested in that. But when we move here, let me say t to the power 0 is 1. So when I raise an exponential function e to the power, let's say 0, the result is 1. Okay, so with that principle, we can continue. So this side, we know it is 0. So we have 0 minus, now everything we have here is 1. But remember, f bar of 0 is not 0 because it is a derivative function when t is equal to 0. That is why I said you should look at transform of derivative. When t is equal to 0, this is the same as what? X naught. Okay, so we will apply that. So this times f1 of 0 plus s integral from 0 to infinity f bar of t e minus st dt. Okay, now since we don't need this 0, we can get rid of it. we can use this to multiply the 1, and the result becomes minus f bar of 0 plus s integral from 0 to infinity f bar of t e minus st dt. I'll rewrite this function, then we continue. Okay, now from this result, okay, so let's break this down. Okay, so now when we look at this side from here, we can see it is similar to what we have here. So I want you to look at this very carefully. The Laplace transform of a second derivative is the second derivative function times e minus st, okay, dt. When you look here, we have f bar first derivative function times e minus s. So this is representing the Laplace transform of a first derivative. So we can write something like, but Laplace transform of this f bar of t is equal to integral from 0 to infinity f bar of t e negative st dt. Okay, so we represent all this side with this one to make it simple. So let's substitute this one. So this result is giving us minus f1 of 0 plus s, then a Laplace of f bar of t. Okay, so this is it. Now I think you can leave your answer here, but we can also change this to notation. Remember that a Laplace transform of f of t is the same as f of s. Now if we want to use notations, we can break this down. You can choose to leave it here, but it's very important you break it down. Okay, what will be the result for the Laplace transform of f bar of t? You should know it. I did this in the previous video when I started, I said it. So let's write that one down. But the Laplace transform of this one, f bar of t, when you solve this, the solution will give you this same result. Now watch this very carefully. This same result, but this time we remove this and then this. So minus f of 0 plus s, the Laplace transform of the main function f of t. Okay, you just take off this. When you solve the Laplace transform for this one, which is this side, when you solve this, the solution is this. Okay, so we are going to substitute this here so that it will be easy for us to deduce it using the notations. Okay, so we can now pick this result and substitute it here. You don't need to show this work, or if you want to show, you can now pick this result. Wherever we see Laplace transform of f bar of t, we substitute all this result. So this is giving us minus f bar of 0 plus s multiplying, now we put in this one, minus f of 0 plus s Laplace transform of f of t. Okay, so now let me close this. So here, this is where we are going to apply transform of derivative, the video I said you should watch in the beginning. So now watch this very carefully. Now when you look at this one, the main function f of t is equal to x. When t is equal to 0, we have f of 0, which is the same as what? 0. Now watch here. What is f of 0? The one we have here, f of 0 is the same as what? x0. Let's do it on a rough sheet. Now, look at here very carefully. What do we have here? F of 0. It is the same as what? x0. So you can represent this side by what? x0. Then let's move on to the next one. If it is a first derivative function, f bar of t is the same as x dot. At t equal to 0, we have f bar of 0, which is the same as x1. Now come back and look here. What do we have here? Negative f1 of 0. Forget about this negative. We can represent f1 of 0 with this result, x1, because they are the same. Okay. Now what do we have here? F of t. What is the Laplace transform of f of t? Because this is telling us take the Laplace transform of f of t. What is the Laplace transform of f of t? Watch here. The Laplace transform of the variable x is the same as x bar. Laplace transform of x is the same as Laplace transform of f of t, because we said let x be equal to what? F of t. So this side, all we need to do is to represent this by x bar. Okay. So now, if we want to deduce this, it becomes very simple for us. f1 of 0 is the same as what? x1. This is negative. Plus, we have our s into bracket. We have f0, which is the same as what? x0. So we have minus x0 plus s. Now, Laplace transform of f of t from the paper or from that video we learned is the same as x bar. So this is what? X bar. Okay, now you can use this to multiply through. This is negative x1 plus, and because I wrote plus here, let's multiply this one first. This time this is giving us s squared times x bar. Then this and this will give us minus sx0. We can now rearrange this starting from the highest power. So this is the same as s squared x bar minus sx0 minus x1. So now you see, from notations, we have been able to reduce the solution of the Laplace transform to this form. Remember that you can also represent this f of t with the Laplace transform of f of s. Okay, we can use f of s to represent, leave them in what? f10, negative f0, and then f of s. That one too is correct. So finally, the Laplace transform of f bar of t is equal to s squared x bar minus sx0 minus x1. In terms of notations, you leave your answer like this. Or if you do not prefer this one, you can leave your answer in this form by taking Laplace transform of f of t equal to f of s. So that will give you minus f1 of 0. This time this will give you minus s f of 0. Then watch carefully. This time this will give you plus s squared. What is Laplace transform of f of t? We know it is f of s. So we have f of s. S squared f of s minus s f0 minus f bar of 0. And this will be your final result. So you can convert the Laplace transform in this form using notation, or you leave it in this form. Any of them is correct. So if you want to leave it in this form, when you get here, you just write this answer down here. But if you want to convert to notations, then you can leave it in this form. All right, so this is Daniel. Thank you very much for joining me. Okay, so I'll end it here. This is Twitter Think. Please support this work if this is useful. I hope you got the understanding for this particular solution, and I'll see you in the next video.